Dear viewers, welcome to our online lesson, and this is part of the remote learning that we are having today. We are carrying out a series of lessons, and today in our mathematics lesson, we shall look at the topics that we have learned so far in Form 3, and we are preparing for the Kcse mathematics. So our lesson will primarily be on Kcse mathematics revision, which will cut through mathematics paper 1 and paper 2. Welcome to the lesson. I am your online teacher, Mr. Steve Gitao. In our today's lesson, straight away, I would like us to highlight the topics that we shall cover. Trigonometry in Form 2, we shall have a question there. We shall have a question on equations of a line in Form 2. We shall have a question on matrices, which is drawn from Form 3. We shall have a question on surds, which is drawn from Form 3. We shall look at question number 5 and 6 on solution of logarithmic equations. Here we shall have two questions. This is some work which we covered in Form 3, and we shall also have application of laws of indices. This is a common area which is normally tested in the Kcse, I beg your pardon, mathematics paper 1 or paper 2. And then we shall also have a question on making a variable the subject of the formula. In short, we are preparing to have about 10 questions in our set 1, and in set 2, we shall examine more questions, especially so as those covered in Form 4. This lesson is suitable for students in Form 4 and those in Form 3 who are gradually learning on the topics that we have highlighted so far. Straight away, let us go to question number 1. Learners, let's have your notebook, and in one or two questions, I'll give a takeaway assignment. Let's look at question number 1. We may be given a question that reads, given that sine 2x is equal to cos 3x minus 10, 3x minus 10 degrees. The question is, find tan x. Find tan x correct to four significant figures, and this question is worth 3 marks. So how do we solve this kind of a question? In the sense that most learners, I'll show you the common mistakes learners make in this particular question. So the most important thing, let us first of all look at the theory behind this question. A learner is supposed to recall a Form 2 concept that says when we have cos A being equal to sine B, then the rule is that A plus B, the angle A plus B should be equal to 90 degrees. Indeed, those angles are supplementary. Learners, I would like you to take your calculator and let us verify this one. We punch in sine 20. Take sine 20, and from the calculator, I'm getting 0.3420 in four figures. Then I also need to take cosine 70 from the calculator. So I need cosine 70, and I'm getting 0.3420. I also want to believe that that is the value that you have gotten. So what are we learning from this? You find that when two angles add up to 90, the two angles add up to 90 here, their sine and cosine are equal. Two angles adding up to 90, their sine and cosine are equal. So that is the concept that we should apply in solving this question. So straight away, let us look at that. We get that 2x is our first angle. When I add it to the other angle, 3x minus 10, I get 90 degrees. That is the concept that we should have. And so, putting like terms together, what do we get? 2x plus 3x gives you, or gives us 5x minus 10 is equal to 90. We shift this onto their side by adding 10 and 10 here. You get 5x is equal to 100. And at this point, we divide by 5 on both sides, then we get that x is equal to 20 degrees. Now we come to the question. The question was, we find tan x. The question was, find tan x. And that means we can come in here and say, therefore, tan x is equal to, we can read this from the calculator or from the mathematical table, that is tangent of 20, and I'm getting the figure 0.3639 and another value here 0, like that. Now, if we look at this question, already we have the accuracy of our answer being defined. 4 significant figures. We are supposed to give our answer to 4 significant figures. So we need to come back and reduce this to approximately 0.36. We look at this third and fourth figure, and actually the fifth. This will give us 4 significant figures, 1, 2, 3, 4. Now, and straight away, let's look at the marking. The marking to this question. When the learner is able to have that, we award M1. When the learner gets that, we award an M1, and this we give you A1 at this level, at that level. If a learner gave the answer at this level, then it will be A0 because his or her answer is not to 4 significant figures. So this is extremely important. However, let's look at a case whereby a learner gave his answer as 0.364 with the idea that this 0 is not important. Well, this learner would not get the accuracy mark because his answer is to 3 significant figures. So this will score A0 and it is not accurate. So that is a concept which I would like us to undertake, and that is in question number 1. Let us look at question number 2. Question number 2, which is going to be drawn from maybe before we look at question number 2, I would like to give an assignment, a takeaway task. Down here, a takeaway task. This is an activity which our learners, I would like you to undertake. Activity 1. I would like you to look at this one. Given that sine x into that is sine x plus 60, sine x plus 60 is equal to cos 2x. Find the value of tan x plus 60. Find the value of that. So in your free time, work out on this one, and our expected answer is 2.7475, when that answer is to 4 decimal places. When that answer is to 4 decimal places. Let's look at question number 2. Let us continue. In our question number 2, we are given a line joins point A and B, where A is 2, 5 and B is 6, 12. So A is 2, 5 and B is 6, 12. Find the equation of line AB in the form ax plus by plus c is equal to 0. So this is the most important part of the instruction. In this set, I would like you to notice that I am emphasizing on the ability to follow the instructions. Ability to follow the instructions. Right, let's look at this question. The first step is to look for the gradient. The gradient of AB, which should be given by change in y, 12 minus 5 all over 6 minus 2. And that gives us 7 all over 4. 7 over 4. And you can leave that in that form, that gradient in that form. Then we want to get the equation of the line. So we shall let a certain point P, x, y, be on line AB. And the theory here is that points on the same line, straight line, have equal gradient or have the same gradient. So if we take px, y, and this one, we shall have 12 minus y all over 6 minus x, and that is equal to the gradient of 7 over 4. Cross multiplying, when we cross multiply, we shall have, therefore, we shall have 4 into 12 minus y is equal to 7, into 6 minus x. And that gives us 48 upon opening the brackets minus 4y is equal to 42 minus 7x. We put like terms together, like the 42, and even the, we obey this kind of formula. So we may decide to have the 4y or the 7x start. So we bring it over here, 7x minus 4y. We add 7x on this side and on this side so that we get the 7x positive minus 4y. Then 42. We erase 42 on both sides, and we shall have plus 6 is equal to 0. 7x minus 4y is equal to 0. Now, in this case, we have obeyed this kind of a rule. Now, I want to remark here that during the marking for such kind of a question, you'll find that when the student is able to get the gradient, we award M1. This organization here for finding the equation M1, and then the final answer here A1. Now, at this point, we need to notice that if a student at this level decided to give the equation in the usual form, y is equal to mx plus c, by possibly writing that maybe negative 4y is equal to negative 7x minus 6, then multiply the root by negative 1, you get 4y is equal to 7x plus 6, then possibly divide by 4, you get y is equal to 7 over 4, x plus 6 all over 4, then this particular student will not score the accuracy mark because the student has not obeyed the instructions given. So it is important that we note that the instructions must be obeyed. In question number 3, we look at matrices. Here, I will also emphasize on an instruction. The instruction is find the inverse of P. In finding the inverse of P, form 3, we notice that we need the determinant of P. The determinant of P is given by product of the leading diagonal, that is 6 by 8, subtract 2 by 9, and that gives you 48 minus 48, sorry, I would like to make a correction there. We have, yes, it's all right. 48 minus 80. 48 minus 18. That gives us 30. Now, for us to get the P inverse, we do 1 over the determinant, and then we exchange values on the leading diagonal. So we get 8 and 6, and then we have these two change their sign to -2 and -9. Now, if a student leaves this answer like that, it does not score the A1 out of the 2 marks, simply because there is an operation which is not yet done here. So we need to come down and say, this is 8 out of 30, -9 out of 30, -2 out of 30, and then 6 out of 30. And where possible, we reduce this to the simplest form. Maybe dividing by 2 gets you 4 over 15, 4 over 15. Dividing by 3 gives you -3 all over 10. Dividing by 2, -1 over 15. Dividing by 6 gives you 1 all over 5. It is important that we leave the answer in the simplified form possible, such that on marking this is the point the A1 will be scored. A1 will not be scored at this level, then obtaining the determinant is an M1. So this student is able to score 2 out of 2. I would like us to move on to question number 4, and this one is on surds. Question number 4, we are looking at simplifying surds. So number 4, we have simplify, we have root 5 all over root 5 minus 2. Root 5 minus 2, and we are saying leaving your answer in the form a plus b root c. A plus b root c, where a, b, and c are rational numbers. A, b, and c are rational numbers. So that's the question. Simplify root 5 over root 5 minus 2, and you leave it in that form. Once more, our lesson is primarily on helping the learners follow the instructions. The instruction in this question is how you are going to leave your question, the form in which you are going to leave your question in. This is very, very crucial, so that the A1 mark is not lost. Straight away, let's look at it. We have root 5 all over root 5 minus 2, and in this one, we should multiply by the conjugate. The conjugate to this is root 5 plus 2, which we multiply on both sides of numerator and denominator. Opening up the brackets, root 5 times root 5 is root 25. Root 5 times 2 is 2 root 5 all over root 5 by root 5 we have agreed is root 25. Root 5 by 2 is 2 root 5 minus -2 by 5 is -2 root 5, and we see here -2 times 2 is -4. So if you look at this, we are going to have root 25 being reduced as a 5 plus 2 root 5 all over root 25 is a 5 minus this subtracts out and you get -4, and this comes to be 5 plus 2 root 5. Okay, so this comes to be 5 plus 2 root 5 all over 1. And this should reduce to 5 plus 2 root 5. And this should be our final answer. Now, let's look at the marking to this. When you multiply by the conjugate, you get an M1 out of the 3 marks in this kind of a question, a short question. When we are able to work out this portion and open up the brackets, you get the second M1, and they should be visible. And then we wait for the final answer. The final answer should not be at this point. A1 is scored here. If a learner leaves the answer with the division of 1, if the learner leaves the answer with this 1 intact here, then he has left the answer with some unfinished operation. He has left the working with some unfinished operation. So we need to remove the 1 because dividing a number by 1 is that number. So we give it at that level. And that makes it extremely important. So let's look at question number 4. I beg your pardon, it should be question number 5. Number 5 reads, solve for x in the equation 2 log 15 minus log x is equal to log 5 plus log into brackets x minus 4. This is a question that requires the learner to have knowledge on the laws of indices and partly laws of logarithms. I think the bigger portion here is on laws of logarithms. Which ones are these? We look at when logarithms are being added, the numbers will be multiplying. When the logarithms are being subtracted, the numbers will be divided. And then there is this part here which is tied partly to that law of logarithms that involves the index 50 power 2. So we shall look at that in a very short way. We are saying that when we have log A plus log B, it is log A times B. Then when we have log A divided by, when we have log A minus log B, this is equivalent to log A divided by B. This is the numbers divide, the numbers multiply. And in this case, if you have A, B, or rather we can have B to power n, then and you take its logarithm, then we normally say that this index or the power comes in as a multiplier here, n log of b. With this knowledge, then we can very easily work out on that, and then you look at what is a hidden trick in such kind of question. So the question becomes logarithm of 15 squared will be divided by x. So this becomes the numbers will be equal to logarithm of 5 into x minus 4. This is what we have said earlier in row number 1 and row number 2, and this is the application that we are having here. We are given this, we come to this level. So if I drop the logarithms and open this bracket, we shall have 225, the square of 15, all over x is equal to 5x, 5 times x, 5 times negative 4 minus 20. At this point, remove the x which is on the denominator by multiplying throughout by x. And that gives you 225 is equal to 5x squared minus 20x. We can reorganize this as a proper quadratic equation so that it reads 5x squared, this one, minus 20x. We bring this one to this side, minus 225 is equivalent to 0. At this point, we can reduce this expression or equation by dividing throughout by 5, both right hand side and left hand side. So this comes to be x squared minus 4x, 225 divided by 5. Viewers, compute that from your calculator, and we get negative 45. That gives you 0. So you find that the logarithmic equation now changes to a quadratic equation, which we are required to solve by the simplest approach possible. One of the simplest approaches or methods is factorization. You use factorization method to solve this one, whereby we look for two numbers whose product, I like to write in P, is 1 by negative 45, that's negative 45, whose sum for S is this portion, the middle term here, which is negative 4. So when we look at this, viewers, take time to work out what are these two numbers whose product is negative 45, whose sum is negative 4. And this gives us 9 and 5. Then we think, which one will be negative? If I put a negative 5 here, when I add this, the sum will be positive 4. So negative 9 or 9 takes the negative. These two values, we bring them into the middle term, and we shall have x squared minus, we can have 9x plus 5x minus 45 is equal to 0. We factorize this first part, and we get x is equal to x minus 9 plus 5 into, we factorize 5 out, we get x minus 9 is equal to 0. So in this case, the factors become x plus 5, x plus 5 into x minus 9, and that gives you 0. So in this kind of a situation where two numbers multiply, one of them is equal to 0. Which one? So it is either, we say it's either x plus 5, which is equal to 0, which gives you x is equal to negative 5, or x minus 9 is equal to 0, and therefore x is equal to 9. Now, viewers, this is now a very crucial point. If a learner leaves these two answers here, he or she is not going to get the A1 for the answers. Simply because we are supposed to check. We check back on our question, will x is equal to negative 5 satisfy this kind of operation? The answer is no. Viewers, please on your calculator, punch logarithm of negative 5. You find that it is not defined, math error. So this is not possible, and so we should be able to disqualify it. We must write down there, disqualify, that this answer has been disqualified, and therefore x is equal to 9, the positive value, which works throughout for that. So how do we mark on this one? We mark by ensuring that the moment the learner is able to apply the rules of logarithm as per this one, being our M1, the learner is able to form the quadratic equation and factorize, especially so M1. I think we shall adjust that mark to when the learner is able to form the quadratic equation at this level M1, and this is A1, and the learner is able to score 3 out of 3. So this is a very important step, whereby only one answer, the x minus 5, is disqualified. So viewers, I would like you to carry question number 6 as an activity. We take it as an activity which we shall work on, and the expected solution is that x is equal to 1. So in a similar way, the only item that maybe we can hint on is how to get the 1. How do you change this 1 into that? So we assume base 10 throughout, and this 1 can be taken as 1 log base 10 of 10. So that is equivalent, simply because logarithm of a or to base a of a is always 1. So with that, I would like you to attempt that question as an activity. So that we may go to question number 7, 8 and 9 are questions on indices. Questions on indices. So let's put it here. Question number 7. Question number 7. This is on indices. The application of the rules of indices in more or greater mathematics. Solve for x. Solve for x in the equation. Solve for x in the equation 8x plus 1 minus 2, 3x minus 1 is equal to 120. Is equal to 120. In this kind of a question, you can see we have some laws of indices. Take for instance, when the bases are the same, we add the indices. The law tested here is when you have base A power m times base A power n, this is A m plus n. So that is the level at which we are starting the question, at this level. So we move from here to here. How come the powers are being added? They must have been, the numbers, the bases must have been multiplying. So we work from that perspective. Straight away, let's work on it. This becomes 8 to the power of x multiplied by 8 to the power 1. Subtract 2 to the power 3x divided by 2 to the power 1. So this is what you're saying. In row number 2, when we have a power m divided by a power n, we get a m minus n, the subtraction row in indices. So the powers are subtracted, subtracting, we divide the numbers, and that is what we have done at that level, and this comes to be equal to 120. We can work out this, and this will give us, this is going to give us 8 into 8x minus 2 into 3x all over 2 is equal to 120. At this level, we can multiply throughout. By 2 to remove this denominator. So the 2 multiplies here and we get 16 into 8 to the power x, 2 to the power 3x, the 2 cancels out by 2, and that comes to be 240. At this point, we have base 2 and 8 is equivalent to 2 power 3. So this can be shown as 16 into 2 power 3 multiplied by x minus 2 power 3 raised to power of x, 2 raised to power 3x is equal to 240. We can simplify this. If we can write 16 multiplied by this term as a, subtract what we can see here as 1 of the 2 power 3x. So viewers, I would like you to see the simplicity here. 16 items called 2 to the power 3x. 1 item called 2 to the power 3x. In fact, we can say this is equivalent to 16a minus a. So that this comes to be 15 of the items called 2 to the power 3x. And that is equivalent to 240. At this point, we divide by 15 both sides. By 15, that is 240. We punch on our calculators. 240 divided by 240, we divide by 15. We get 16. So 2 to the power 3x is giving me 16. Let us work it out here. And 16 can be equated to 2 power 4 by factor method. And that means 2 to the power 3x is equal to 2 to the power 4. And therefore, once more, 3x is equal to 4 and x is equal to 4 over 3, which is 1 and 1 over 3. 1 and 1 over 3. Now, that is a very good discussion there on the application of laws of indices in this kind of questions. Let's do the marking. When the learner is able to break this down, especially so at this level, whereby you've broken the indices and you brought them to be numbers, this is called an M1. when the learner is able to have the unknown on one side, that is 15, 2 power 3x is equal to 240, and 1, and this is an accuracy mark A1. It is important to note that it will be incomplete, to be wrong, to say that x is equal to 4/3. This is an answer with some unfinished operation called division. So it is important that we are able to work out this and look at the steps, and we can review this over and over as we solve question number 7, number 8 and 9, which I'm going to give as an activity. Let's continue with question number 8, which is an activity which I would like you to try, and I'll only provide the expected solution. You work it out and you find that x should be equal to 1 in number 8, and we work out also number 9, and we expect the solution that x is equal to 1. So we can engage on this in our subsequent interactions until we are able to solve these two questions. Straight away, let's move on now to question number 10, which is on making a given variable the subject of the formula. In this is a topic in Form 3, and there is some idea which I want us to capture here. Number 1 is you remove the denominator. That means y into cx squared minus a will be equal to b minus bx squared. Open the brackets, you get y cx squared minus ya is equal to b minus bx squared. At this level, the learner is able to earn an M1. Now, the other method mark will come when the learner is able to put like terms together. That is y cx squared minus bx is equal to, shift this on the other side, b plus ya. However, sorry, this is x squared. However, the mark is not yet mature until we factorize. We factorize the x squared and we get yc minus b is equal to b plus ya. And at that point, that aspect where x is now 1, x squared is 1, we are able to get an M1. In the last step, we have x squared is equal to b plus ya all over yc minus b. And this is the second step to concluding this, whereby we shall have x alone, which is what we were asked, being the square root of b minus ya all over yc minus b. However, very, very important and very, very crucial is the fact that the square root of a number which is positive may either be positive or negative. The square root comes out that. So this must be shown because we need to apply that rule. The square of a number which is positive gives two results, and it can either be positive or negative. And at that point, we get an A1 and the student earns 3 out of 3. Viewers, as we come to the end of the lesson, I would want to make a few remarks as a conclusion. That the purpose of this is to guide you through the revision. We have tackled about 10 questions, and some of them are activity questions. Please work on them and keep on following through until we are able to get our expected top mark. I would like to thank you all for joining me in this lesson, and please let us meet in our subsequent lessons. And for more information on this, you can join me on my YouTube channel, which is that has the handle at Steve Getau, at Steve Getau, that is 660. So you can view more of such kind of material on the YouTube channel, and we are going to benefit. Thank you and see you next time.